would like to ask anything, I'm happy to take the questions to start off. If you have a question, please feel free to unmute and ask, or feel free to post a question. So maybe just to back up a bit, my name is Vineet Balasubramanian. I'm a faculty in the Department of Computer Science and Engineering at IIT Hyderabad, and I'm the instructor for the Deep Learning for Computer Vision course. So thank you for your interest in taking this course, and hopefully it's of some use to all of you. But I'm happy here to answer any questions. Maybe you can post your question by unmuting or ping it on chat, or probably fill up the Google form with the question and it will show up on our screens. So happy to take the questions any which way. If any of you want to get started.
Sir, I have a question. Thank you. So in computer vision, like initially the deep learning area was led by computer vision with segmentation and object detection, other tasks. But looks like off late, there is more talks about NLP being the leading upfront, and seems like more unsolved problems with NLP. So what are some of the unsolved problems in computer vision that the current research is going on, and how does that build on what's already solved, like object detection and segmentation kind of problems?
Got it. Yeah, thank you. Thank you, Ramesh, for the question. So I wouldn't like to say that, I mean, there are more unsolved problems in one domain or the other. I'm not sure if it's exactly like that. But if you just go back and see the last 10 years, I think historically in 2012, when AlexNet was created, which was the real start of the boom that we're going through, it was computer vision that was at the forefront. I think the first few years, I think all the developments, AlexNet, ResNets, all of them were actually in computer vision, then NLP. Somewhere around 2017-18, when transformers came into the mix, I think NLP started coming to the forefront. For multiple reasons, I think the architectures were more sound. But also, if you look at it in a different perspective, I think the most commercializable technologies are in NLP. So if you look at what do big companies in the world need to work on, forget the open problems, what do they need to work on for their businesses? It's probably web-based text analysis and mining and crawling and all of that, right? So that's become the main focus, because that's what gives money, and that's what governs the economy of these kinds of companies. So I think that's also a large factor in why NLP took over computer vision. But otherwise, these days, I think there's also a lot of talk about how both the modalities are probably important for each other in a way. I think multimodality seems to be the way to go, or using language. I think language is fundamentally important, because whenever we learn something, that's how we convey something to others, right? So even if we could analyze images, the way we convey that understanding to somebody else is through language. So language becomes, in that sense, very core. Now, coming to the other part of your question as to what are the open problems in computer vision, there are quite a few open problems, right? So it's similar to NLP too, right? So even in NLP, there's a lot of concern as to, are there any open problems at all? Because there are foundation models like the GPTs and BERTs that actually work on all kinds of text. Then what do you really need to solve is an open question there. Very similar in computer vision too. I think there are foundation models these days, like it started with CLIP, BLIP, and all of them. These days, there's more on segment anything, SAM, OpenETR, and many other detection and segmentation models that have also like vision language models like Lava, Flamingo, so on and so forth. Many of which are foundation models, and they seem to be solving many tasks by themselves. Right? So that's obviously true. I think to a large extent that is happening. But having said that, I think there is a lot more to do. It is just that our tools have become very strong. Right? So the tools we had earlier, if you maybe even go through the course itself that we covered, the tools that we had 20 years ago were image processing, edge extractors, and feature extractors, right? So then fast forward 10 years, in the mid 2010s, the tools became convolutional neural networks. Last 3-4 years, the tool has become transformers, right? So the tool has become powerful. It does not mean that all problems are solved. I mean, even if you take a problem like object detection, right? So then even that problem is not solved if you start using, say, videos from drones, or you have data where the objects look very small. Right? So it's still an unsolved problem. So which means a lot of these tools which can be used for general purpose understanding have become better. So one way to understand this is that a lot of these foundation models are like imperfect priors, right? So they may give you good detection performance, segmentation performance until a certain level. Beyond that, you still need to make them work for different domains, make them work for different applications. So those remain open problems. So that definitely remains an open problem. But I understand that these are all incremental things, right? So it's only about adapting and things like that. So there are, maybe I can divide my thoughts in, let me see, 3 different ways at least I can think of as examples of where there are open problems in computer vision. One segment of the problem, which is becoming very popular today, is around 3D computer vision. Right? So how can I get 3D information from 2D data? So if I gave you an image, can you automatically tell me what is the 3D layout of this room? So I'm sitting in a room. Can you automatically find out the 3D layout of this room? It's still an open problem. Right? So it's, to some extent, these are, I think there are growing solutions for this problem. But I think it still remains an open problem. Now, you could extrapolate this to anything 3D, right? So if you have an image of somebody walking down a street, can you actually get a 3D perspective of everything going on in that street, right? Or what are the different objects and what 3D orientation configuration those objects are, is still an open problem, right? So the entire space of 3D from 2D is a very open space at this point in time. I mean, a lot of people working on it, but it's still open at that from that perspective. A second direction I would say is going beyond supervised learning, right? So the success of whatever we see around us today, be it like all your segment anything, or like all your foundation models, all the convolutional neural network models, all are if you gather large amounts of curated labeled data. So the challenge in the real world is that you may not have access to curated labeled data all the time. So what if you have, to some extent, the last week of lectures covered topics like zero-shot learning, few-shot learning, continual learning, so on. So those remain open problems. There are solutions to those problems, but I think when you combine those in newer settings, as I said, if you use foundation models in these kinds of settings, they solve the problem only partially. So they don't solve the problem completely. So how do you get that last 10% of performance, or last 20% of performance, right, becomes important and an open problem. And I think a third direction, right? So I would broadly say the first direction was 3D. The second direction was going beyond supervised learning, various settings within that, domain generalization, domain adaptation. All of those settings are still open depending on how challenging those settings are. Some of those settings can be easy, but some of those settings can be difficult. A third direction is integration of vision and robotics. So how do you not only do vision, how do you also manipulate your environment using vision becomes important. Okay? So far, the aim of computer vision is largely been about perceiving your environment. Right? So if you look through the course and look through all applications like detection, segmentation, face analysis, depth estimation, all of them are about how you perceive your environment. Right? So what do you see in your environment? How do you understand what's in your environment? But the next question is, what if you want to manipulate your environment? So that still is an open problem space at this point in time. So those are at least some of the problems that I can think of. And beyond that, I think this entire space of responsible AI, explainability, fairness, privacy preserving nature of problems, robustness, I also think is a fourth pillar, which is still, I wouldn't say solved by any means at all. Did that answer your question partially at least?
Thank you, sir. It helps a lot to think about, the challenges and opportunities to learn more about in this field. Thank you.
Absolutely. And I think in all of these, trying to think multimodal, bringing vision and language together is perhaps the way to go. So I think while computer vision is a field by itself, I think increasingly things are multimodal, and probably humans are multimodal too. Right? So right now you're probably seeing me, listening to my audio, and probably reading some text too. Right? So and that way of learning also becomes important to consider as we move forward. Okay. Any other questions that anybody wanted to ask? You can feel free to unmute and speak, or type your question, on the Google form. Okay, just a minute. There's a question on chat. Let me look through that. Yes. Maybe Tyagarajan, can you voice your question? Maybe if you can voice your question with this problem, whatever you have typed here on.
Hello, am I audible?
Yes, yes, yeah, yes, you are.
Yeah, so I just had this question. So this question was in the assignment, we had to choose whether this statement is true or false. So in your lectures, it was, there was just a single statement where you explained that when you have the dimension of the hidden layers is more than the dimension of the inputs. There is a possibility that the network might just copy the inputs and give out a trivial solution. Is that always the case, or because I just had a look at more details about what overcomplete autoencoders are, and there are quite a few papers which actually, I didn't go through the entire details, but it kind of exploited the overcompleteness nature in order to solve non-trivial problems. So, can it be used to solve non-trivial problems, or is it kind of some kind of a limitation?
Understood, got it. I think, obviously, there are always exceptions to, to everything in a sense. But I think, maybe you should take it in the spirit of saying that I think what we mean is that we don't want to memorize, right? So often overcomplete architectures can memorize your inputs. Now, memorization can be useful in certain applications, right? So memorization can be useful. But in machine learning, when you apply these kinds of architectures to learning problems, our objective is always generalization. That means we want it to work beyond the data that is already seen, right? So in those kinds of settings, these things often have problems when you go to non-trivial settings. I think that's the more general statement. I'm not exactly sure what kind of papers you are referring to and what kind of problems they were solving. It's possible. As I said, in general, we don't want to memorize, right? So, but memorization is good for certain applications. If somebody wants to leverage the memorization capabilities of a neural network for certain applications, absolutely yes, they turn out to be very useful. Right? But in general, when we talk about it from a prediction perspective, we always want to predict on, we also always want to measure the performance on generalization, where you want to see its performance on a completely new input, and their memorization is not good. Right? So probably the statement was made in that context. Is that what you were referring to? Or I'm not sure what other kinds of non-trivial problems these systems were solving.
Okay. Yeah, got it. Fine.
It's a general statement. I completely would understand your viewpoint that yeah, it can be useful in certain other statements, but when you talk about generalization, that's something that you don't want to do.
Okay, thanks.
Any other questions? You can feel free to ask any question related to aspects of the course or otherwise related to computer vision.
I have another question, sir.
Sure,
yes, sir. So this is on quantization. So as the models are getting bigger, right? So initially when they talk about float 32 to float 16, that was easy to envision. Okay, so you are giving away some floating point precision. But then when they talk about int 8 or other forms of quantization, that's very, I'm not able to fully understand it, because aren't weights in general, like, small numbers floating point numbers. How does quantization down to int 8 or other things to compress the model really trained in a neural network setting?
Got it. Got it. Yeah, thank you. And I think that's a nice question. And I actually think that is the challenge there, right? So if you talk to a lot of people working, I'm not sure, maybe you are, if you talk to people working in the embedded systems industry and related industries, I think that's a common, it is not like if you downgrade your weights to, or quantize your weights to int 8, things just work as it is. Not really true. Right. So in fact, it is a struggle to get them to work. So that's exactly for the reasons that you're saying, right? So you do need the precision of the weights, but we have no choice. When we want to bring these kind of networks down to smaller sizes and you want them to run on embedded systems, we don't have a choice but to consider this, right? So I think we are forced by architectures to somehow bring down the precision of your representations of weights so that you can fit it into smaller form factors and smaller compute footprints and so on. Right. So, I mean, in my opinion, there's no other choice but to try doing it. Not that bringing it to int 8 will keep the model's performance exactly as it is. Not really. Right. But we want to try to see how do you bring down the model with minimal loss in performance. Right. So definitely you're going to have a loss in performance, but with minimal loss in performance is what we want to aim for. Right. So in short, you're right. I mean, it is hard to make it work as it is in the 16-bit or 32-bit kind of a system. But then we want these kind of systems to be loaded onto, I mean, the general philosophy is that not all systems you can access a cloud and get a response from. Right? Certain systems you can, where in embedded systems, you can take a user input to the cloud and run it there and bring it back. But there are many other systems where you don't want to do it. Could be security reasons, could be a geographical reason where you're in a very remote location where you cannot do a client server architecture. And so in which case you have to run it on device. Right? So then you don't have a choice but to make things work on int 8, right? So, or even lower for that matter. Did that answer the question? Or yeah, if you have a follow-up question, please feel free to ask.
Thank you, sir. It helps. So also maybe 3-4 years back, there was this discussion about pruning. Like once you train the model, you prune some weights where the weights are 0, and then to make the model smaller. But these days, I don't see that much discussion around pruning. Maybe that is again in the embedded systems they talk about it. But these days they let the model grow really big and so like how do so I'm just trying to understand what is the current thinking behind these design of models. Is it to make it really large, sufficiently large that it can address the problem and use other ways to address the latency and inference, or is there still thoughts about how do we prune the model to a smaller size?
Okay, that's actually a good observation. Yeah, so I mean, I've thought about it myself that yeah, the number of people talking about pruning off late is reduced. I agree completely with you on that. So just thinking why that could have happened. So I do think pruning works, right? So, and I think one of the reasons is there is this broader understanding that almost 90 to 95% of the weights are close to 0 in a trained neural network. So if you can prune them out and work with only the remaining weights, then you can deal with sparse matrix multiplication and so on, for which we have faster library routines. Right? So that makes it easier to work with sparser, it makes it more efficient and you're able to get faster results. Probably what has changed in the last 3-4 years are transformers. Right? So a lot of the pruning work used to be done with the non-transformer kind of architectures. The VGGs, the ResNets, and so on and so forth, where pruning was quite common. I think I have not personally seen too much work on pruning with transformers per se, and transformers are more recently diffusion models for generative AI. Right, so these kinds of models I have not seen too much of pruning per se. I have seen one other thing that has, I mean, in the past for model compression in general, pruning was one strategy, but there was another strategy like knowledge distillation, where you take a large teacher model and distill it to a smaller student model. I think that has become more the option besides quantization. Of course, quantization becomes a more straightforward way of doing things. I mean, straightforward in the sense that you could do it with respect to a particular hardware. But I think the knowledge distillation has seen more efforts in the recent past, especially with models like transformers. There have been papers in the recent past trying to show how if you're having a very large foundation model, how can you do it with the foundation model, with a model which is 50x its size or 100x its size or so on and so forth. There have been, that space has been active. But only thing is a lot of those efforts have been more towards knowledge distillation rather than pruning. And if any of you know otherwise, please feel free to correct me on this, but that's been my observation at least. So given that, yeah, I'm not very sure as to, I've not seen too many papers on pruning with transformers. It could be the reason that because you rely a lot on self-attention, the number of MLP weights in transformers is far lesser compared to the other, or the importance of MLPs in transformers is far lesser. I wouldn't say number of weights. The importance becomes far lesser. It's possible that that could be a reason why pruning is not much of a choice. I've not studied this myself much. But knowledge distillation methods are very much there, right? So there are the other kinds of methods where you can distill a large transform model to a smaller model that gives similar outputs, so on, right? So that is definitely there. So I would like to say it's because of transformer architecture, but I would ideally probably read up a bit more and think through this, but it could be because of transformers at least. But that's an interesting question.
Thank you, sir. Yeah, thanks. I was also thinking that maybe the hardware is not as efficient when you have sparse models. Maybe the GPUs have gone very good at working on these sort of dense matrices, but I'm not sure. Yeah.
I'm not sure whether pruning was made. The people who first came up with pruning immediately came up with an FPGA and ASIC design, if I'm right, based on the initial pruning. But yeah, I do agree. I mean, the way I was seeing it, I'm not sure if pruning was more hardware driven rather than efficiency in general, not necessarily based on hardware downsizing. But you could, the moment you have sparser matrices, sparse matrix multiplication is a well-known thing. So you have well-known routines for doing sparse matrix multiplication. So it becomes faster in general. So I actually think that is the benefit of pruning rather than from a hardware perspective. But you're right. I know the initial people did try to bring it on hardware, and it's possible that hardware doesn't really benefit from pruning. That may be a valid point. I agree with you on that.
I have one more question, sir. On like these days, like with Chat GPT and other models, it's getting to be like even SAM segment anything. Like it seems like there is one very large model that can do almost many tasks, right? But I think before maybe 2-3 years back, it used to be that you would have a large backbone model and then you would fine tune to a specific task within a small data set that you have looked at. Like, are those days still relevant, or are they, are we moving more towards a general purpose understanding model that can do a variety of tasks? It is trained on a lot of tasks probably, but so it's more general. But I feel like although it's useful in some scenarios, but for a lot of everyday tasks, we probably want the model to be really good at a specific task that it is put in. So how do we reconcile these two worlds? Because it's like everybody is fascinated by Chat GPT being able to do a lot of different things, but maybe if you compare Chat GPT on a one task with a model that is trained specifically for that task, like how I'm feeling that the model specifically trained, like even a ResNet model on ImageNet might be better at it than ChatGPT. unless unless they just trained on even more data that it's actually beats that performance with the model. But I feel like as an industry, sometimes people are fascinated by APIs and very large models. Like, how do you reconcile that with task specific fine-tuned models, and how are they relevant in today's industry?
Got it. No, I think that's an excellent question. I think something everybody is asking. I think have things changed? Yes, right. So since last 3-4 years, have things changed? Absolutely, yes. So definitely the arrival of foundation models and models like ChatGPT and LLMs have definitely changed things. Right? So it's about how and where we have to repivot. Maybe that is the broader question here, right? So we have to. I mean, we live in an age where I believe beyond just technical advancement, I really think what has really changed things is the open source nature and the extremely fast dissemination of methods, right? So if somebody comes up with SAM 1 week ago, somebody can build a new version of SAM across the world in a completely different geography a week after that, right? So this was something that was unheard of in civilization before. So that has really largely catapulted what the speed of development of new things. So which means we have to keep repivoting to something new once in a while, at least, if not every few months, at least once in a while. So I think that's the times we are going on. And I'm not sure if we have a very convincing answer at this point from the community. I do think people are still trying to figure this out. But I still feel that, I mean, I'll go back to one of the phrases that I used earlier, which is, be it SAM, be it foundation models, be it LLMs, I think all of these are best treated as imperfect priors, right? So they are imperfect priors, right? So they work in a lot of general purpose settings, but try to stretch them a bit beyond, they start breaking down, right? So SAM works quite well, segment anything works quite well. Will you deploy it on a driverless car to segment out pedestrians and traffic lights in drivable area? Not probably. I don't think we have that much trust in segment anything. Right? We probably have to fine tune it, test it, try it for different domains, so on and so forth. So it becomes an excellent prior to start with, but I still believe that we need to do that last mile of trying to adapt it to a particular data set, a particular task. As you rightly said, I mean, any specialized tasks, these things may not work as well. So I think we have to repivot, but we still have to fine tune and adapt it to different domains, tasks, and specific settings that we may need to. I think that's where we are at this point in time. Things may change, right? So things may change and there could be better models that come. But roughly this looks like, and it's extremely, probably the general performance of these models can improve over time, but I still believe that we would need to do that last bridge of engineering or fine tuning to make things work on systems. I do think that it may be very, very hard to generalize that and come up with a unified system for that part of it. Right? So that's very, very, very difficult. And in my opinion, at least unlikely in the near future. Not sure if I addressed your question, but hope that answers your question at least.
Yes, sir. Thank you. I have one more general question on how can this MLAI community help the broader society in India? What are some of the areas where you can apply what's already researched, understood, and proven to be working, okay, into practical settings? There seems to be a slightly disconnect that a lot of this MLAI is led by the large companies to improve the targeting or specific things of their interest. But how do we disseminate that into common people's applications? And are there companies that do that effectively?
Got it. Thank you for that question again. So, I mean, this is a discussion that's had in many, many forums. I am a part of many such forums where I think obviously there is a lot of passion and interest in contributing to the Indian setting and probably seeing how to leverage these developments here. I think there are multiple dimensions, multiple ways of thinking through it. I'm not sure if there is a one very clear answer. And I mean, firstly, the good thing is, I think when there are many factors aligning to make a larger impact of ML and AI on the Indian ecosystem in general. So I do think that is something that's happening. I personally know many efforts that are brewing as we speak at this point in time, including like LLMs in the Indian context, building large scale, very large scale LLMs in the Indian context. I personally know many such systems that are brewing at this point in time. Right? So definitely it's in the works, may come out sooner than later, but definitely something that many people are trying to see how do you directly influence. I think, I mean, a few broad scattered thoughts I would say is that one large thing has been that we don't have very well-defined public data sets from the Indian ecosystem for people to solve. Right? So we need large ones, not just very small ones that small groups collect, but very large scale ones. To a large extent, I think as an MLAI community around the world, I think we have been able to solve problems where we have been able to collect large corpuses of data. And it's as straightforward as that. Wherever we have been able to collect large corpuses of data, we have been able to solve problems. So why are we so good at Google Translate, or why do we have systems that can work so well in the web scale data? Because we have organizations that can crawl web scale data and collect the data and build models. Right? So I think that capability to collect data, harvest data, and be able to build those models becomes extremely critical, which is something we have not done effectively in India. Right? So to take data, anonymize it, and put it out, right? So it's a bit sad that while we work on these problems, we still use data sets. Like if it is object detection, we use a COCO. If it's segmentation, we use a Cityscape, and all of these are based outside India. Right? So it would be wonderful if we switch this, right? If we created data sets and put it out there, and the world worked on these kinds of data sets. At the moment we did that, the problems will start getting solved. Right? So we just need to do that more effectively, I think. So which is something we have not been able to do. So creation of data by itself, I don't mean small scale data. I don't mean like lab level data. It has to be large, like really large efforts, concerted efforts on collecting data sets and putting them out publicly. Again, not collecting data just for a few of us to consume. I think the more you put it out and the world works on that data, I think our problems get solved. Right? So that's one way of looking at it, at least. So that's something that I feel is one direction that is important as we go forward. Otherwise, I personally do think it's important. So I think data is critical. In my opinion, that's the most critical piece if you want to solve, right? So let's say you want to use MLAI to solve some problem in healthcare or agriculture or something like that. Without data sets, we cannot solve those problems. And data set collection takes a long time. It's a very cumbersome effort, and often an effort which one or two people cannot just manage. Right? So you need a group of people to collect these things and put it out there for people to solve. Right? So I personally think data is a very critical piece of why we have not been able to do that. I mean, there are not too many data sets from India that people around the world work on, right? So we don't have that. And that's something that I think is important to change if we want to do this. But otherwise, I do think there are a lot of companies that are using computer vision NLP to solve problems in the real world. So the other critical aspect to think to also look at is often what problem somebody solves is governed by the economics of that problem. So which of these problems can get revenue, right? So which means often the problems that get solved are the web scale problems, right? Because that generates maximal revenue when you can consider web scale advertising and things like that. Right? So naturally, the problems that have the maximum potential of revenue are the ones that get solved. Right? So if whatever problems we see solved in front of us, whatever we use of machine learning, are problems that can be monetized easily. Right. So if you ask why don't we have problems to probably fix the roads on the street, fix different problems that we see around us, unfortunately, the monetization of those aspects is not as strong as others. Right. So I mean, the world is governed by economic needs, and that becomes the big in my opinion, factor in choosing problems which can be more impactful. How can we change this? I don't know. I mean, love to hear your thoughts on that too. But how can we change this? I do think we probably need organizations that exclusively work on this without having a direct economic impact, right? So then you can take problems that can solve more socially relevant things rather than just economic impact, right? So we probably need organizations that do that. But I also believe there is one chicken and egg problem there, which is to build such organizations, you also need a very strong pool of researchers in the country that work on such problems, that know how to convert such problems into solutions, right? So we also have, I don't think our talent pool there is very, very strong yet, right? So I think it is growing each year, but I don't think our talent pool is very, very strong to set up very high-end research organizations, right? So that's another reason why we don't have too many of deep tech companies in India, because I think it's a supply chain kind of a problem. It's a demand and supply kind of a problem. So the moment we have a very strong excess of supply of researchers in the country, I automatically think organizations such as this will start getting set up to employ them, and probably problems will get solved too, right? So, but yeah, those are some loose thoughts. At least I wouldn't say that that's a very complete answer, or that I'm an expert in these things, but at least those are my thoughts.
Thank you, sir. That makes sense. Yeah, I agree. Yeah, thank you. I think the data being the problem, I didn't realize that. That's very, very good. Thanks for the insight. And also, India is a large market, and we have a very diverse, at least from a language perspective, we have a very, very diverse language, and a lot of people speak each language. So I think there may be opportunities to improve, bring services that actually make that language differences go away with these machine learning systems. Yeah, I think.
And I think, I mean, now going back to that question as to, I mean, there are a lot of efforts in the country, by the way, on trying to do natural language processing with Indian kind of languages, even for multinational companies, because even for them, I think it's a lot more revenue if they can access a lot of the population across beyond the English barrier. So then I think their reach becomes more too. So definitely a lot of work in this space. But again, going back to this point about that first question that you asked as to NLP is popular, computer vision, what are the open problems? So one of the reasons NLP is popular is it's easier to monetize, right? So it's far easier to monetize. So it's obviously more popular from that perspective, right? So maybe people working in computer vision like us should ideally see how do we monetize these aspects, and that then can directly lead to development of technologies, developments of data sets to have more progress.
Thank you, sir. And also your thought about, we have to think of the world in terms of multimodal these days. So it's not just NLP, but very likely there is a image or video associated with it, and maybe even speech, but at least the image and video, image and text seems to be a rich set of information. So that also was very helpful. Thank you so much for that.
Thank you for the questions. Yeah, thank you. Very interesting questions. Thank you. Okay, anyone else? Maybe we should let others ask a few questions too. Anyone else with questions on the course? Otherwise.
So I had a question.
Sure.
So I was searching for ways to increase accuracy for a model, and like searching through those processes, I found a concept called hybrid modeling, where we use multiple models to increase the accuracy. But as a programmer, I face the issue that it increases the complexity and computational time a lot. So shall, as programmers, we focus only on accuracy, or we shall focus on decreasing the complexity and the computational time too?
Got it. Okay. Yeah, I'm not very sure about the terminology of hybrid modeling. If you mean ensemble models, are you referring to ensembles of models? Would that be the same thing, or is this something different?
So like an example which I was working on, so it was basically detection of brain tumors, where they used models like ResNet as well as Inception V3, combining both of them to return.
Yeah, that would, I mean, in technical parlance, we'll call that ensemble learning. Yeah. Yes. So, I mean, going back to your question, it depends, right? So it depends on applications. So in certain applications, probably computational complexity matters. In certain other applications, it does not. So you ideally have to, and it's a trade-off. Right? So one of the limitations, I would say, of the way machine learning has been done largely for the last 10 years is that we always taught accuracy or a related system metric, right? So be it AUC in segmentation or mean average precision in detection, so on and so forth. We always relied on one number to judge the goodness of a method, right? So, and it worked for us. For many years, it worked for us because it helped us compare models. Maybe I should take you back a little bit back in history for you to understand the importance of this, right? So if you go back until maybe I would say 2007, 2008, right? So go back 15 years or so. The way research or development of algorithms used to happen around the world is I would develop a model and I would say I get 90%. Somebody else would develop a model and they would say they get 87% on their data. And we would now say that I would say I get 90%. Somebody would say they would get 87%. I would test on my data. They would test on their data. And this is how things used to get published, right? So at that point in time. Right? So ImageNet and related datasets were actually ways to standardize and compare different people. Right? So different people. So which means if I built a model, because ImageNet came into the picture, I could now compare my performance with a model built by my colleague sitting in a completely different country or continent. Right? So these kinds of data sets were actually developed for comparing. Until then, it was a very strange situation. Right? So, and when you are comparing models, it's always easier to compare on one metric. Right? So accuracy became that metric. Right? So everybody thought, okay, now till now we were all developing different models without even seeing who's doing what. Now let's all get onto the same page. Right, and for the next 10 years or 15 years, a large part of the next 10 to 13 years, at least till a year or two ago, I think we've always been focusing on accuracy. Right, accuracy has been the primary thing because it's easy to compare. Right, I can look at one number and say whether I'm doing well or that model is doing well, so that then I can deploy it. But I think the last 2-3 years or so, I think everybody is bringing up this point that it's not just one metric that counts. Right, so ideally, in different applications, you could use more than one metric to make decisions. What would that metric be depends on what application. So if you think computational complexity is a problem for your method, I agree with you that you may have to use only a single model that uses accuracy, but it's a trade-off. You may not get as good a performance as an ensemble model, but that's why it's a trade-off. Right? There are two metrics that you want to maximize. And the moment you want to maximize more than one metric, it's more or less going to be a trade-off. And you more or less need to be looking at Pareto optimal things rather than optimal things. Right? So things that maximize both to an extent. You cannot get maximum values on both parameters. Right? So which is the case here? So in this particular case, I think it depends on the application. If your application doesn't mind the complete computational complexity of the ensembles, I think you should go ensembles. Right? So it depends, or hybrid models, as you mentioned. Right? So I think it depends on your application. If your application can tolerate multiple models, by all means, right, you should go for it. So in fact, I think this is something that everybody has been talking of late, and I think it's not done as well, is participative design. Right? Participative design is something that we as a civilization have mastered in software development. We start with the user requirement specification, then we build the software, then we have like test cases and validation, verification. All of that is completely well designed as an entire process. Sadly, I think when we talk about machine learning, we are still yet to formalize that process well enough. And ideally, it would be nice to have a participative user requirement specification phase where somebody tells you, okay, this is what I want from your system, right? I wanted to predict, I think I would want accuracy of a certain number, but I don't want more than 2 seconds late or 2 milliseconds latency. And this is what I want, right? So the moment people start specifying that, it's easy for you to take a call. You know that even if you use 2 hybrid models, if it's under 2 milliseconds, it's okay, because that meets the user requirement specifications. Right? I know I gave a long answer to a short question, but I hope you got that point.
Yes, sir. Got it. Thank you.
Evening, sir.
Yes, please.
Sir, I'm actually currently I'm BTech student last year, and I'm actually working on a project where I'm detecting fabric defects.
Sure.
So when fabric is created, there are certain kinds of defects in the cloths, and I'm trying to like automate that process, like detection of those processes. I was not able to find many like contemporary research paper regarding the, except one in which they used like a SAM model and then fine-tuned it for this defect detection part. Do you have any other recommendation that like areas of path which area like models which I should explore in fine-tuning, any other opportunity that could be explored?
Yeah, unfortunately, I've not worked on that problem or come across that problem much. So I can assume, I can understand when you say that there's not been much literature there. So even I have not seen much literature on that particular problem. And I'm quite sure there are many, many such problems where there's not enough literature. Using SAM does make sense. I mean, using segment anything and trying to build on top of it makes sense. But I do think you first may need to build a decent data set to study all of this. Right? So I'm not sure if you have that already or if you need to do it, but I do believe that you need to create a data set first. There
are some data sets which already exist in this manner.
I see. Okay. I mean, if there exist data sets, I'm quite sure there will be some work also.
Yeah, there are some work, but it's not contemporary work. It's like using CNN, like simple, like it's log CNN, and like brute forcing through CNN. It is not, and they get like 80% accuracy on that particular distribution, but they don't even try to check for other data set or they make own data set. Like so, it's like there is no contemporary work. There is some work, but it's just like fine tuning this like the brute forcing through CNN kind of.
Understood. Got it. Yeah. So I do think, I mean, the scale of data sets that were required for CNN kind of architectures is different from the scale of data sets that are required for transformer-based architectures. So if you want to use more contemporary work, yeah, you probably need to collect more data. I'm not sure if those data sets are already large by themselves. I'm not sure about that. If they're already large, that's great. I think you can probably train transformers and see how they work on such problems. I think segment anything is a good start. I would definitely think starting with segment anything and then trying to fine tune it does make sense. But if the data set is small, it was meant for CNNs, you may have to think about collecting more data or enhancing it in some way to train good models. But otherwise, I mean, that seems like a nice problem and a good adaptation of existing models.
Like, should I explore like detectons and stuff for this? Like fine-tuning detector?
No, so, okay. I'm not very aware of the data set or the problem per se myself. Yeah. But the first question I would have is, what is the formulation of your problem? Right. So, I mean, especially when you're working on applied problems, it's extremely essential to understand how are you formulating the problem? Because segment anything is segmentation, detectron is detection. Right. So the question is, how are you formulating your problem? The moment you formulate your problem, then you can decide which kind of an architecture to use. Right. So since you said some fabric detection, I'm not sure whether is it a detection problem? Is it an anomaly detection problem? Is this a segmentation problem? I think there could be multiple ways of.
There are. Yeah.
So which way are you going? Which way does the user want it? Right. So that's the more important point. In what way does the user want this problem to be solved? Do they want it to be solved as segmentation? Do they want it to be solved as detection? Ideally, you want to take the simplest setting that solves the user's requirements. The simplest setting, right? So I'm sure all of you must have heard of the Occam's razor principle that if you had multiple things that solve the same problem, always choose the simplest one, right? So you ideally want to find the simplest setting that solves your user's requirements. The moment that setting is finalized and your user agrees with that, then I think it should be a state. If it's a detection problem, I'd completely agree with Detectron, assuming that you have enough data to train transformer models. But it's a segmentation problem, obviously SAM and its variants and newer models is what you would want to go for and probably fine tune them. To summarize, I think you should also formulate the problem carefully in such a way that the user is accepting of that formulation.
Yeah, thank you, sir.
Sure. Absolutely. Okay. Meanwhile, maybe I'll just take a couple of questions that were online on the forms that were circulated. I'll also answer them now before I'll come back to the other thoughts again. I think there was a question from Yogesh that asked, in examination, programming questions will be provided with Google Lab for execution, or will programming questions be tested on syntax knowledge? Not really. There may be just one or two questions on like how you use NumPy or SciPy, but nothing at Colab level or nothing programming at a complete deep learning algorithm level. So hopefully that clarifies one question. I think there's another question from Pavani. I'm not sure if she's here. Okay, yeah, I think Pavani is here. The question is, you wanted explanations for every question in the assignment. Thank you for sharing that. Yeah, I did notice that you mentioned that you requested this in earlier feedback forms. Apologies that we missed that. We will do our best to see if we can at least retrospectively try to explain the solutions to the different problems. So yeah, we'll definitely work on that. Sorry that we did not do that earlier, but we'll definitely do that. Okay, now coming to Tyagarajan's question, what's the scope for research in non-deep learning based methods? Okay, that's a difficult question. Maybe do you want to voice out what kind of non-deep learning method you had in mind? Did you mean like SVMs and AdaBoost and like more machine learning things, or did you mean like more image processing things like edge detection and feature extraction and SIFT?
Yeah, so I actually work in the area of image processing.
I see.
So I had worked on things like graphical models based methods for image processing. But I mean, in general, I mean, maybe within the deep learning realm of methods, are there any specific sub areas within the deep learning realm where there is scope for research, maybe in optimization or things like that? Where
obviously, scope for research. When you say optimization, you mean like a proper mathematical optimization or just optimization of parameters, which was the two?
Mathematical.
Understood. Okay. That's a difficult question, to be honest. Right? So I do think unless the community comes up with an alternative for backpropagation, I do think backpropagation is here to stay. I think end-to-end learning and backpropagation is hard to beat. The only other thing that I think can do better than that is probably going reinforcement learning way and learning policies, I think. That's probably the other direction in which you can learn, where you are learning based on a delayed reward that comes after some time. But otherwise, I do think, at least in the near future, backpropagation, gradient descent are going to be very important. I'm going to probably read your question in two ways. One is you were trying to ask the question as to is the scope in non-deep learning methods in image processing, and probably you were also asking about where can you use optimization methods to solve this, right? So I do think graph-based models will make a comeback, right? So that, this is just my personal thought. I do want to say that it's not like this has to come true, or that it's the absolute truth, and this is just in the spirit of open discussion. I would think that graphical models will make a comeback. I do feel that graphical models in the past relied on feature extractors, and what we have thanks to deep learning are excellent feature extractors. Right? So far, for a large part, we only wanted the last layer problem to be solved. Okay, that's the part that we changed as classification, detection, segmentation, and things like that, with some changes to architecture. But for a large part, we relied on just good representation learning, right? So that's all we needed to solve many other problems. But as we go deeper into problems like scene graph understanding, where we want to understand the relationship between objects in a scene, object affordances. I mean, I talked about, if you recall in the beginning when Ramesh asked the question, what could be open directions? I said that robotics and computer vision, the combination is interesting. When you want to manipulate an environment, right? So when I want to take a mug from one desk and put it on another desk, I'm manipulating the environment. At that point in time, I also have to understand the relationship between objects in the scene. It's not just a perception. I need to understand some relationships. I think at that stage, graphs come back, because I hope you agree with me that graphs are a perfect way of representing object A stands on B or object B stands on C. Things like that become very important. Another thing is when you want to reason your decision, right? If I want to say that I'm calling something a cat because it has 4 legs, because it is a furry coat, because it has pointy ears, right? So I'm trying to say that, okay, I'm calling this a cat because of this and that and this and this, right? So you could again look at that as a graph or a symbolic way of doing things. I do feel that those kinds of methods can make a comeback for doing that level of processing inside deep neural networks. So I do think that is something that is growing, but growing a little slowly. Nascent is what I would say, but growing a little slowly. So I do feel that those kinds of methods would become relevant too, right, as we go. For a large part, I look at deep learning as solving the perception part of the puzzle. And now reasoning based on the perception part of the puzzle is still, we are doing it in a brute force way at this point in time. I feel there is scope for making that more formal. And the moment we make that more formal, all the graph-based optimization, all of that will come as not that deep learning will get replaced. Deep learning will become building blocks to solving those kinds of problems. So I don't expect deep learning to get replaced, but it gives you perceptual building blocks to solve these problems. So if I say that I'm taking a mug from place A to place B, it is perception that told me it is a mug. It is perception that this told me that this is desk A. It is perception that told me that this is table B. Right? So that's where deep learning is really good at. So, but then you need maybe a graphical or symbolic way to actually realize that, okay, this is, you need to take this from here to that and put it on that. Right? So these kinds of things become, I think graph-based models become a little bit more natural to solve these problems. And I do believe that those kind of things may start coming up soon, is what I would believe.
Okay, thanks.
So regarding exam, like what will be like the expectations, right? I mean, should like will most question come from like the formulas, like for example in many assignment the questions are just direct application of the formulas taught in the exam. So should we expect that kind of questions too, or should we expect more conceptual questions more?
I would say conceptual questions, but I mean, if you ask me, formula of convolution is something we would expect you to remember.
Yes,
right?
Of course.
Something as basic as convolution or things like that, we would expect you to remember. But most other things would be more conceptual based, right? So I wouldn't expect it to be like something that, I mean, where you need to remember every formula or every loss function or everything in the network. Basic things we would expect you to remember, of course, right? But otherwise, it would be largely conceptual. So based on how you understood different aspects of the course. I hope your question is answered, Swanim.
Yes, sir. Yes, sir. It is answered.
Okay. 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 A couple of questions on chat. Let me just quickly go over them. Pavani asks, my research is on cancelable biometrics using encryption. Okay, I see. Okay, in which way vision tasks are applied on this? Which deep learning models are used? I'm not very sure what cancelable biometrics mean. If you mean that biometrics where I forget a certain group of people over time, I mean, if that be the case, I can tell you. But encryption, I'm not very sure whether encryption is directly relevant here. I mean, encryption can be done for any kind of image model or task per se. So I'm not quite sure whether why you want to.
Sir, good evening. This is Pawan. My question is, I'm working on transferable biometrics. Like nowadays, the biometric authentication is very critical to secure. So my task is to secure the template of related multimodal biometrics by using an encryption technique. So in that task, how the deep learning or computer vision tasks are applied on this?
Yeah, I got that part. I mean, the part that I wasn't sure about was why is encryption a problem? I mean, that can be, anything can be encrypted. A model weights can be encrypted, data can be encrypted. Where you mean like privacy preserving, or did you mean encryption?
No, sir, privacy preserving. Yes, the correct word is the privacy preserving.
Okay, understood. Got it. Okay, all right. Okay. Yeah, I think there are lots of vision work in that space, right? So it's a pretty hot space. I think trying to do privacy preserving vision biometrics is pretty hot, right? So where you want to be able to detect a person without infringing into their privacy, right? So which means that I think there could be multiple ways, which means I could like blur out a face, but I still want to recognize who the person is from other aspects of them. Or that's an internal thing which I don't display, but I use some image features to recognize a person rather than actually not blur a face. So, I mean, I think it's a very important vision problem, and I think all deep learning models are relevant, right? So anything that's vision based is relevant to this, right? So anything, I mean, face recognition models based on CNNs, transformers, I think all of them are completely relevant to this. Right? So it's a very important vision these days.
Oh, okay. Thank you. Thanks.
So, I mean, I would highly encourage you to please do go to conferences in computer vision like CVPR or ICCV. I don't mean physically go, but if you go to their websites and look at workshops in CVPR and ICCV conferences, you'll invariably find some conferences that are related to biometrics or privacy preserving. I would suggest you to go through papers related to these topics in those kinds of specific focused workshops. They may give you a little bit more insight onto what are the deep learning models that the community is using on these problems. I mean, I don't directly work on this, so I don't know them off my head. But I would recommend you to go to these top conferences, look at the workshops on these topics. They will tell you the specific models that you can adopt.
Yeah. So can you please repeat the conference names?
CVPR, Computer Vision and Pattern Recognition, and ICCV, International Conference on Computer Vision. I mean, these are considered like premier conferences on computer vision. You can just search CVPR 2023 or ICCV 2023. You'll find their websites online. So just go to the workshops in them. You'll find workshops on biometrics or on privacy preserving vision. You should go through the papers in those workshops. That will be the ideal thing for you.
Yeah. Thank you, sir. Thanks a lot.
Okay, next question is from Yogesh, which is my project is on object distance measurement from camera with 99% accuracy. Which deep learning neural network will yield high accuracy? Very hard to give a very direct answer, but I hope you are looking at all depth-based depth estimation networks. I personally don't work on it, so I don't know the latest, but I do know that there used to be GeoNet a few years ago, which is, I think, still popular, but there may be more recent networks too. I hope you're looking at those kind of networks because they are meant for depth estimation, which automatically also gives you an estimate of distance. Right? So you can translate the depth to an estimate of distance. I hope you are seeing those kinds of models. That should help you choose the right model. I mean, I think it's important to identify the right set of papers that you may want to look at. That will automatically tell you what models you want to choose. And in this particular case, I think you may want to be looking at depth estimation networks. GeoNet was one that used to be popular. Geo is GEO, not JIO. GeoNet was one that used to be popular a few years ago, but I assume there may be more off late. But I would highly recommend you to look at those kinds of models.
Understood, sir. Thank you. But it also depends upon annotation of the data sets, right? How in order to yield the accuracy.
Absolutely. I mean, I'm assuming that you have annotated data sets, right? So that's why I was saying earlier that, I mean, you need that if you want to solve these problems, right? So absolutely, yes.
So in annotating the data sets, if it has been around 20,000 images, it's been okay. Or it needs more than like lakhs of images to train.
20,000 is decent. 20,000 is decent.
Okay.
Right. So even there, I would suggest please fine-tune models. Don't train models from scratch.
Okay.
There are already depth estimation models that are available online. Take one and fine-tune it on your 20,000 images.
Okay. Understood, sir.
Because they are, I mean, because depth is something that does not change with different countries.
Hmm.
Right? So, I mean, it's the same, right? So a model that was developed in the US may work quite as well for even an Indian context.
Okay. Thank you. Thank you, sir.
Okay, I think Swarnam's question, any idea of adding diffusion or VIT for future version of this course? We are thinking about it. I mean, the TAs of this course were also on this call. I think they've been suggesting that to me too. So we are thinking of a part 2 of this course where we talk about the more newer developments in computer vision rather than take away what is already there. We believe that what has been covered is also useful. So we are thinking of a part 2 of the course where we want to cover more newer topics that are trending at this point. So definitely thinking about that one. Okay. Okay. I think there is a personal question from Pavani. Maybe I'll respond to that separately, Pavani. So maybe if you can send me an email, it'll be easier for me to respond to that. So you should be able to find my email ID online.
Sir,
Yes, please.
I also wanted to inquire about like the internship opportunity. I believe I mailed you a few days ago. Right? Are there any other are there any other conditions other than like topping this course?
I mean, generally we hire based on the need. So based on the needs of the different projects that we have. So that's the only thing. I mean, if at a particular point in time we just hired students and we don't have an immediate need, I mean, that's the other factor that could decide. But otherwise, personally, I'd love to see if we can hire students that do well in this course and have them join us. I mean, I've had students in the past. I think there are students here too on this call who've done well in this course and joined our group. So yeah, definitely happy to do that. Okay, I think maybe there's one last question. Maybe we'll stop with that. I know that we have short time. It's from Saurav. Looks like it's a direct message, but the question is, could an artificial intelligent agent be created in the future that is capable of simulating the consciousness of a specific person? Okay, that's a very, very deep question. I'm not sure how simple it is. I mean, so you have to keep in mind that at the end of the day, humans have emotions and machines don't. Right. So there's definitely an aspect of it which we know we can never replicate. Right. So the emotional aspect of it. Right. So definitely we know that there are some differences. I mean, in terms of technical capabilities, what can we do with our physical sensory abilities? Yes, I think everything that we do can potentially be done by a machine over time. But there are aspects of humans that we know that a machine can never really simulate at all. So I think speaking about consciousness, it's a far ask at this point in time. So I do think that's, I mean, at this point, it doesn't look like something that will happen in the near future. But I mean, since you said simulating the consciousness of a specific person, yeah, if you're talking about trying to build systems that adapt to a specific person, live symbiotically with a specific person and help them solve problems, absolutely yes. Right. So I do think, I mean, we will see technologies. I mean, to some extent, our mobile phones and smartwatches are already that. Right. They're already agents that live with us. And I mean, if you give it enough permissions, can probably adapt to your schedules and help you with daily life. To some extent, we already have those systems that simulate the behavior of a specific person and live symbiotically with them. As I said, our smartphones are those. But going beyond, I think, is a little harder. As I said, we have the emotion barrier where humans can emote, whereas we know that computers and machines cannot. So that barrier is always going to exist. But until that barrier, I think whatever can be done, I would assume is something that machines also can support us. Right, I hope that partially answered that question. Okay, I think a follow-up question from Saurav, maybe we'll absolutely stop with this, which is, could a new generation of Gen AI be created in the future where a highly sophisticated language model capable of simulating the consciousness of a specific person answering questions based on knowledge derived from publication statements previously given interviews? Okay, I think it's the same question. I think probably develop that question a little bit more. I would say yes, right? So, but for the emotional aspect of it, the other aspect of a person, if that was interesting, right? So can be done, right? So if you probably trained, I think people have done this a long while ago, right? So in fact, this is not even new. Go back 15 years ago, maybe a specific answer to Saurav here. Go back 15 years ago, or probably even longer, when RNNs were first developed, people used RNNs to write Shakespeare sonnets. That should straight away answer your question, right? So which means if you trained an RNN, not even a transformer at that point in time, 15 years ago, just on Shakespeare's creations, only based on publications written by Shakespeare, it could now compose sonnets that were similar to Shakespeare's sonnets, right? So if you, I mean, that focusedly do something for modeling one person and generating content related to that person, it's possible. I think there have in the past been RNNs that have been that have developed, that have written speeches similar to Barack Obama's, written sonnets similar to Shakespeare's, many other such things, right? So I do think that is possible, but the word consciousness is something that I would probably refrain from. I do think that may be a little difficult to achieve because there's a barrier of emotion that's between them. But the other aspects of living, so the physical aspects of living, I do expect that it's possible to do it if that's what we wanted to do as a civilization. Okay, Siddharthan asks, can we have a Q&A review for the final exam for everyone in NPTEL portal? I'm not sure what that means. Q&A review on the NPTEL portal. I'm not sure if you can speak up your question. Do you want us to Q&A review on the portal? What can you speak up your questions, Siddharthan?
So actually, can you like the discussions made for the final exam? Can we like have the details, like question and answer type?
Discussions made for the. You want sample questions? Is that what you're asking? I don't
So
know.
like doubts regarding the exams and the answers. Like how will we attend this test? Is this fully computerized? Something like that.
Oh, you want like about the format of the exam? Is that correct? If your question is about the format of the exam, NPTEL office would be the right people to ask that. I mean, but we are happy to answer the questions. Please do ask questions, right? So we'll be happy to respond. Right? So if you can ask these questions on the portal, we'll be happy to respond and clarify any of these questions. Right?
Okay, sir.
I couldn't get exact. If your question is about the format, yeah, please do ask, right? If your question is about sample questions, we can do that too, but I couldn't get exactly what you wanted. But if you wanted format, yeah, absolutely, yes. Just if it'll help us if you ask us questions and we'll be happy to respond.
Yeah, like many students have doubts regarding the exams, how it will be, what type of questions will be asked in the exams.
Got it.
So,
Okay.
yeah,
We'll
doubts regarding this. Okay.
Sure, yeah. Happy to do that. Yes, definitely.
Yeah, I think in like the previous NPTEL courses and stuff, like the distribution of the questions that comes from the assignments are actually different from the distribution of question that end up in exams. So for example, like sometimes in many NPTEL exams, like 10%, 20%, the part of the syllabus comes out like 90% of the exams. So like there's a, and even like the types of question being asked differ, like sometimes completely. Like for example, in many courses, there are no numerical questions in assignment. And then in the exam, they only give numerical questions. So I think it would be like very beneficial to get like a sample of the distribution from the exam itself, instead of like judging it from the assignment.
No, in this case, I think the questions will be similar to your assignments, right? So similar to your quizzes, barring the programming part, right? So you won't have programming questions in the final exam, but otherwise the questions are going to be similar. I think you had numerical questions even in the quizzes. It's going to be similar even in the exam, right? So it's going to be similar, at least in this particular course, it's going to be similar. Since there are The course TA is also here. I'll also let them answer this if they have anything to add. Rishabh, Sairam, if you had anything to add, you can add.
Also, yes, I think from the calculation front, they would be a bit easier than the assignment since you only have 3 hours. But yeah, I mean, it will be quite similar to what you have already covered.
It's going to be similar. Yeah, so there's no difference. But for any questions on the format, I mean, it's a general format that any other NPTEL course follows. So Siddharthan, maybe if you still have that question, you can just post it on the portal and we'll be happy to respond.
Okay, sir. Thank you.
Okay, I know we have gone over by 15 minutes or so. Maybe we can stop here. Thank you for joining in for the live session today. And I mean, very rich discussion, I would say. Thank you for all the questions. I personally enjoyed being a part of the conversation here. And if you have further questions, please feel free to send an email. I mean, please bear with me if I don't respond immediately, but please give me some time to respond. But otherwise, happy to respond and answer any questions even directly by email.
Sir, congratulations for getting your paper accepted in UniReps.
Oh, thank you. Thank you. Thank you. Thank you. Okay, so let's stop here for today then. And email ID is there online. I mean, if you just go search my name on Google and just say IIT Hyderabad, you should find my email ID. So you can probably send questions there. I'm happy to respond. Okay, let's
Thank you, sir.
Stop here for today. And thank you again for all the wonderful questions. And thank you for spending time joining this session also. For those of you writing the exam, yeah, all the best for the exam, and happy to answer questions on the paper. Thank you and have a good evening.
Thank you, sir.
Thank
Thank
you.
you, sir. Thank you so much.
Thank you, sir.